Hi, good evening. Well, we're going to talk about our lab practice, number one. In this lab practice, we're going to basically control the brightness of a LED. We are going to use a basic control circuit. Now, as you can see from the circuit in Proteus, we used the main component. It is a transistor BC547, which its collector, it is connected to the LED. And we are going to apply a square signal to the base of this transistor. This will help us to turn it on and off depending on the signal. And we are also going to look at the output signal and the generated signal that we are going to connect to the base. Basically, these square signals are is going to be between 0 or 5 volts. And we're going to mess around a little bit with the frequency to see what is happening to the circuit. We also have some resistances connected to the circuit, and of course, oscilloscopes to see the signals.
Okay, once all devices are connected, we have a frequency of 0.1 Hertz, and we notice that the LED is barely flashing. So as we increase the frequency in this signal generator, the LED start to flash faster. And then this is how we can control the flashing of the LED until it can be left completely on. All this is possible if a very high frequency is maintained so that the LED stays on. This happens similar in our homes, since our lights is oscillate at the frequency of 60 Hertz, and the lights are constantly turning on and off, but we cannot perceive it due to our physical abilities. This happens with the most of the lights in which we can control the frequency of its input signal.
So finally, I'm going to talk about that these kind of circuits also can be used for digital circuits. As we can see, when we have a 1 in the enter, we have a 0 in the outside. So as we can see, we can do digital circuits with, it could be to do it digital signals. And finally, actually, I'm going to talk about the brightness of the LED that we can modify by decreasing the voltage or increasing the voltage. So right now it's turned on but when I decrease the voltage, the brightness of the LED start to turn off. And when I increase again the voltage, the brightness of the LED turn on. So actually, I'm going to talk about the PWM signal, but the main problem with the Proteus software is that the VSM signal generator tools doesn't have the duty cycle tool. So we decide to move the same circuit to Multisim software. So let's go to Multisim. And there is, in Multisim, we designed the same circuit, but in this case, the signal generator, it has the duty cycle advice. So let's look what happened if I increase the duty cycle with the blue signal, that is the input signal. So let's look what happened. So just to remember, the PWM signal is the time that a square signal stays in high or in low. So let's see what happened. And I'm going to stop at here. Just look, the blue signal, it start to increase the time that it pass in high state. And just as an example, I'm going to reduce and look the LED, it starts on and blinking very fast. And I'm going to decrease to see again what is happening. Just look the blue signal and you can see that the stay in low increase. So in conclusion, we can say that if it's a very low percentage of a duty cycle, the PWM signal stays in a very low for a long time. But if we increase the duty cycle, the PWM signal stays in a very high level in a very long time. And I think that that's it for this circuit. Be happy, teacher.